Hello everyone, myself Swati Sripal Halunde. I am working as Assistant Professor for the Department of Electronics and Telecommunication Engineering. Today I am going to discussing with you regarding types of modulations. Okay, there are basically two types of modulation by using analog communication as well as digital communication. For analog communication, there are different kinds of modulation techniques. What are the different kinds of modulation techniques are involved in analog communication? That now let us see. Here I have mentioned that type of modulation. First one is the continuous wave modulation and second one is the pulse modulation. Okay. Basically, there are two types of signal as we know. First one is the continuous signal and second one is the discrete signal. For continuous signal, the signal which is going to vary according to instantaneous of time, that signals are considered as a continuous signal. And for pulse modulation purpose, we are considering discrete signal. That discrete signal came under the type of digital modulation. For continuous wave modulation, here that continuous wave it is divided into two categorization. First one is the amplitude modulation and second one is the angle modulation. In that angle modulation, there are furtherly two combinations are present. First one is the frequency modulation and second one is the phase modulation. For every kind of a modulation, what is the definition of modulation? First of all, that came in our mind. Now let us see about the definition of modulation. Modulation means according to instantaneous value of modulating signal, the values of the carrier signal is varies, then this process it is called as a modulation. And for the conversion of a signal into waveform, there are three parameters are important. First one is the amplitude, second one is the phase, and third one is the frequency. Amplitude it is going to consider about the height of that particular signal. Phase it is going to consider the shape of that particular signal, and frequency it is going to considering the width of that particular signal. Along with this, here we are discussing about continuous wave modulation. Inside that, three types of modulation as a amplitude modulation, frequency modulation, and phase modulation. And for the pulse modulation technique, the pulse modulation technique it is furtherly divided into two categorization as analog modulation, digital modulation. First, in analog modulation, there are three types of categorization. Uh, it is nothing but pulse amplitude modulation, pulse width modulation, pulse position modulation. For this digital modulation system, pulse code modulation, delta modulation is present over here. And we are going to discussing about briefly all these types of techniques. First, here I have defined the amplitude modulation. In this amplitude modulation, what we are looking over here regarding to changes or variations in amplitude of that particular system. That means according to instantaneous value of modulating signal, amplitude of the carrier signal is varying and rest of two parameters are remains constant. Then this type of modulation called as a amplitude modulation. Then rest of which two parameter here, rest parameter is frequency and phase. Then another definition for this, sorry, next definition for frequency modulation is frequency of the carrier is varied in accordance with instantaneous value of modulating signal. At that time, phase and amplitude remains constant. This is the definition about frequency modulation. And third definition is about phase modulation. For phase modulation, phase of the carrier is varied in accordance with instantaneous value of modulating signal. At that time, frequency and amplitude of that particular signal is remains constant. Then what are the benefits or need of the modulation? As we know, as we discussed earlier, what are the definitions of modulation? Then now let us see about what are the benefits involved for the need of modulation. First benefit is to reduce the length or the height of antenna. By doing the modulation, we can reduce the height or length of that particular antenna, and it is a more flexible for us for the transmission purpose. Then second is for multiplexing, it is possible to use the modulation. That means multiple signals we are giving as an input for that particular system and single output we are generating from that multiplexing. Then for narrowbanding, to use the antenna with a signal or the same length we are using for this. Then fourth need of modulation is to reduce the noise effect. Whatever the noise is introduced in the communication, it is reduced by using modulation. And last but one, it is um, need of modulation is to avoid the equipment limitation or to reduce the size of equipment. These are some benefits which is done by modulation. Then here I have shown the amplitude modulated signal, how we are generating or how we are getting that amplitude modulated signal. Again, it is important part. For this, here the amplitude of the carrier signal varies in accordance with the instantaneous amplitude of modulating signal. For this, here the amplitude value we have used, and here the baseband signal I have given as a input signal. And here is the carrier signal. I have shown that carrier signal having the amplitude as a AC, and that signal it is a having the frequency more as compared to your input signal. That means what is the definition of that carrier signal? Carrier signal, it is nothing but high frequency signal. And by the combination of both the signal, previous these both the signal, first one is the baseband signal and second one is the carrier signal. Here we are getting amplitude modulated signal. For that amplitude modulated signal, as we are observed that here whatever the modulated signal, modulating signal, that modulating signal, it is acting as a curve shape over here, and inside that curve or inside that envelope, that carrier signal is superimposed over here. Whatever the height of that amplitude curve, that means higher height it is considered as a maximum amplitude, and lower height it is considered as a minimum amplitude. This is all about AM modulated wave. And AM modulated wave, here getting the output regarding to this, it is nothing but AC plus AM. And from this, here I have derived the mathematical equation for this as a carrier signal is given by the equation as a C of t, which is equal to AC cos omega ct, where AC is the maximum amplitude of the carrier signal and omega it is nothing but angular frequency. And as we know very well that angular frequency it is denoted by using the value as a 2 pi fc, and where fc is the carrier frequency, and thus we are going to converting that angular frequency into linear frequency. And modulating or the baseband signal, here we are represented by using the equation as a x of t is equal to am cos omega mt, where am is the amplitude of baseband signal. Then here, for amplitude modulation purpose, the standard equation for amplitude modulated signal, it is expressed as we know very well, the modulated signal, it is the combination of carrier signal as well as modulating signal, and it is represented as S of t is equal to AC cos 2 pi fct 1 plus MA cos 2 pi fmt, where MA is nothing but modulation index of amplitude modulated signal, and modulation index of amplitude modulated signal, it is the ratio of AM by AC. Okay, peak amplitude of the modulating signal divided by peak amplitude of the carrier signal, and A factor it is representing peak amplitude. And thus here we are representing that MA amplitude modulated signal into two domains. First one is the time domain and second one is the frequency domain. Apart from these two domains, first of all here we are going to discussing about time domain representation of amplitude modulated signal. Here, as we have discussed here, S of t, it is nothing but your modulated signal value. That modulated signal equation I have denoted over here. And first term, second term and third term, that is the three terminologies are present over here for this amplitude modulated signal. First terminology, it is regarding to carrier signal. Second terminology, it is regarding to upper sideband. And third terminology, it is regarding to lower sideband. Upper sideband, it is represented by Fc plus Fm. Lower sideband, it is represented by Fc minus Fm. And carrier, it is represented by only Fc. Then this is the amplitude modulated signal which is represented in frequency domain. Previously, as I have told you, that is regarding to your time domain, and here it is present in terms of frequency domain. Then time domain representation of AM wave is given by S of t is equal to AC cos 2 pi fct 1 plus MA cos 2 pi fmt. Then taking the Fourier transform for both the side, and here at the below side I have represented that frequency domain AM signal. Then the modulation index or the depth of modulation is given by that modulation index of amplitude modulated signal. It is shortly represented by small m suffix a is equal to a max minus a minimum divided by a max plus a minimum is equal to am by ac. And the percentage modulation of that modulation index, it is represented by percentage of ma is equal to a max minus a minimum divided by a max plus a minimum into 100. This is the mathematical equation which is used for the representation of percentage modulation in terms of trapezoidal pattern. Then the types of AM with respect to modulation index, regarding to that modulation index, here there are three types of modulation. First one is the over modulation, second one is the under modulation, and third one is the critical modulation. For this, whenever the modulation index should be less than 1, then it is considered as a under modulation, and whenever the modulation index should be exactly equal to 1, then it is considered as a critical modulation, and whenever we are considering that modulation index should be greater than 1, then it is considered as a over modulation. And here I have shown the ratios and waveform structure regarding to under modulation, critical modulation, and over modulation. As we observed over here, as a MA is less than 1, then AM by AC should be less than 1, or AM which is less than AC. This is the mathematical ratio belonging for under modulation. Likewise, for critical modulation, MA means what? Modulation index which is exactly equal to 1. For that case, AM by AC equal to 1, which is indicating that AM is equal to AC. And for over modulation, here modulation index should be greater than 1. That's why AMA is equal to AM by BC AC, which is greater than 1, or AM which is greater than AC. This is regarding to your over modulation. This is all about our that type of AM modulation. Then what are the different conditions are involved in AM modulation? Then what are the types of modulation? What is the definition of modulation? These are the basic concepts we have discussed over here along with me. Okay, thank you.